Good morning, everybody. This is about 285, and on your final exam, there will be 4 questions that I want to give you a big picture perspective here. One of them will be a circuit with several capacitors and inductors, and the answer here relies on you, on us, shorting the inductors. So instead of this inductor, we're going to make a short, and still finding the current through it. So this I1 will be a scalar, let's say 5 milliamps, 10 milliamps, and then the capacitors will be opens. So just drawing this and putting the pluses and minuses so that we know where we're finding the voltage and currents. This is what we're asking for, what we'll be asked to do for steady state circuits. And it will have several capacitors and inductors, usually 3 or 4, so 4 capacitors and 4 inductors. And this is the trick: open capacitors and short inductors. First chapter 7, we worked on this for 2 to 3 weeks. It's always one capacitor or one inductor. And really what we're asked to find is the current through the inductor over time, or the voltage across the capacitor over time, and it can be either step response or source free. So if it's step response, there will be a power supply that's the forcing function for either the current or the voltage. And the answer will be a time dependent function, usually, actually always for the first order, and it's going to be an exponential function with tau. So tau here is super important. Tau is going to be either RC, or tau will be L divided by R if it's an RL or an RC. And the resistance is the Thevenin resistance that the capacitor or the inductor sees. So this is one good application of Thevenin for the resistance here. And now the last month of 285 is second order circuits, but you could also see them as second order differential equations. And we only are asked to solve 2 kinds of these RLC circuits, either the series, so this is the blue circuit here, or the parallel version. So for t larger than 0, you will only be asked to solve either this or this. To solve a second order differential equation, we need 2 initial conditions, and that is part of also chapter 8. You will also have a question on the final exam where we only find initial conditions, and we're going to do this in class, but those are required so that we can then solve RLC circuits, either series or parallel. And there are 2 kinds. So if Vs or Is are different than 0, Vs, Is, the source power supply is different than 0, then it's a step response because I'm putting voltage or current there. Source free means that the Vs after t equals 0 goes to 0, and the current supply, either one of them, also goes to 0. But we'll talk about how to solve this. For us to actually successfully solve one of these circuits, we need these initial conditions. And I used to ask you one question: find initial conditions and solve the circuit. Instead, now I separate, so these here, this will be, let's say, a 15-point question, and this is going to be a 15-point question, and this is 10 or 15, and this is 10 or 15. So this is 60% of your final exam, more or less. So it may change a little bit more, a little bit less of this, but this is more or less what we are supposed to know before the end of 285.